This presentation is a continuation of the email security topic. This week, we will focus on DNS and IMAPS. In our previous discussion about email security, we reviewed the various steps involved in sending and receiving emails using the Simple Mail Transfer Protocol (SMTP). On the screen, you will see a simplified flow of the email process, which will help us focus on today's conversation about DNS and IMAPS. As we discussed earlier, SMTP allows email servers to communicate and transfer messages. The process begins when a transmission control protocol connection is established between the client and the email server. Once this connection is opened, the client sends the message content, which includes information about the email sender, the recipient, the email header, and the body of the message. The server utilizes a program known as a Mail Transfer Agent, MTA, to verify the recipient's domain and determine how to route the message. This domain's verification process is our next focus. After all the data has been transmitted successfully, the connection is closed. For example, if you send an email to a Gmail address, your MTA uses DNS to look up the MX record for gmail.com to identify which server should accept the message. Without this step, the message will have no way of reaching its destination. DNS, domain name system, refers to an email server's use of a mail transfer agent to find an email recipient's IP address or domain name. A mail transfer agent will translate a DNS into an IP address so that the server knows where to send the email. The domain name also stores a mail exchange record that indicates how messages should be routed. Domain name system server installation for Windows can be done using PowerShell or the GUI. In PowerShell, install the DNS role using install-windows feature-name DNS. Then configure the DNS server by adding an IP address. Your current IP address can be found using the getNext IP address. You will want to use this IP address to replace the placeholder IP address stored in the DNS setting. This can be done by entering DNS server settings equals get-DNS server settings-all. DNS server settings listening IP address equals @ This is where you enter the IP address you want to use. Set-DNS server settings. In GUI, install DNS by going to the Manage menu of the Server Manager, select Add Roles and Feature, click Next, then choose Role-Based or Feature-Based Installation, click Next. Leave the default for the destination server, click Next. Click on the DNS server checkbox, click Next. Leave the defaults on the Select Feature screen, click Next one more time, review your options, and click Install. Once installed, the DNS server can be managed from the Windows Administrative Tools menu. In the Properties section, you can enter your IP address by selecting only the following IP address. Because of DNS inherent use of the Internet, it should be secure. Some best practice includes enabling DNSSEC. DNSSEC is a protocol that provides authentication by verifying the security of the domain name by adding cryptographic signatures to DNS records. These digital signatures are stored in the DNS server and help receiving servers ensure that the message being received are not altered en route by the attack. Another further step in DNSSEC is DANE, DNS-based authentication of named entities. DANE for SMTP uses TLS authentication to ensure that the receiving mail server is a legitimate and expected mail server. DNSSEC and DANE enabled together can help prevent email attacks. You can also block encrypted DNS queries. DNS can be encrypted using DNS-over-HTTPS, also known as DUP. This practice protects DNS requests from being tracked or tampered using the same security that websites use. However, for receiving servers, the use of HTTPS makes it harder for network firewall tools to block and monitor. Because of that challenge, some organizations choose to control encrypted DNS rather than to block it completely by routing clients through an approved resolver, so monitoring and visibility are still possible. Domain name system service installation for Linux can be done using a DNS server called Bind. Bind stands for Berkeley Internet Name Domain, as it was originally created at the University of California, Berkeley during the 1980s. Since then, it has grown into the most commonly used DNS server software. It can be used on Windows, but it is mostly commonly used on Linux. Bind is highly flexible and allows advanced configurations for professionals who know how to code in Perl, Python, Bash, or PowerShell. Like other Linux software we have reviewed, Bind is no cost and includes a large user community that can be used for troubleshooting and best practices. Bind can be installed with the command #DNF install bind-utils. IP addresses can be configured in the option statements. Listen-on, port #IP address range. The allow query and allow recursion statements should also be updated to define IP address ranges. Firewall rules should be updated next to allow incoming DNS traffic using #firewall-cmd-permanent-add space service equals DNS, then #firewall-cmd-reload. Finally, Bind can be started and enabled using #systemctl enable-now name. Features that should be enabled on Bind to enhance security include, similarly to the hardening suggestions from DNS on Windows, Bind should also include DNS security extensions or DNSSEC. Bind uses elliptic curve cryptography to verify the data being received to the server. Ensure Bind is running in enforcing mode. This ensures that access will be denied if it does not comply with the policies in place. If Bind is run in permissive mode, it would allow the traffic that violates policy and locks the message. Disable recursive queries, which are DNS lookups, where the DNS server will search for an IP address and return it to the client. The contrast iterative queries where the client communicates with each server that is involved. Recursive queries creates a vulnerability DNS amplification attack, where attackers can use botnets to send a highly volume of queries with fake or spoof IP addresses with very long responses. A real-world example was the Mirai botnets, which took advantage of the open DNS resolvers to launch massive amplification attacks. Restricting recursion in Bind is one of the most effective ways to prevent that type of abuse. Continue through our email process. After emails have been successfully sent, emails are stored in a mailbox and then viewed by the recipient using an email client such as Outlook or Gmail. Email clients can then be configured with different mail retrieval protocols such as POP3 and IMAPS. Let's take a different look at the email retrieval protocol. The most common mail retrieval protocols are IMAP, Internet Message Access Protocol, and POP, Post Office Protocol. Both of these protocols allow an email client to retrieve messages from an SMTP server. The key difference between the two is that IMAP allows users to access their email from any device as the emails are stored on the server and can be accessed via an internet connection. In contrast, POP downloads emails to a single device. Once downloaded, emails are deleted from the server and can be accessed on the user's device even when offline. While this makes POP lighter on server storage, it is less flexible for users who want to access their mail on multiple devices. POP is still in use, particularly in legacy systems or organizations that aim to conserve server space. We covered POP in more detail in our last discussion, but this discussion, we will focus on IMAP. IMAP can be enabled on Linux using dovecot. First, you'll need to install dovecot services using sudo apt install dovecot-imapd and choose IMAP using protocols equals IMAPS. To complete the IMAP setup, you must select a mailbox location. Next, you will need to configure it to require SSL-TLS encryption. For all IMAP connections using the SSL-cert option, you must specify a valid server certificate and private key to ensure that clients can securely connect over port 993. This configuration guarantees that all messages are encrypted and protected during transit. The final steps to enabling IMAPs include setting up a user authentication rules, for example, requiring a password and setting up firewall rules. The best practice for securing IMAPs are ensuring SSL-TLS encryption is enabled. This will ensure that communication is encrypted. The firewall should allow secure traffic on port 993 while blocking unencrypted traffic on port 143 to enhance security. The MailCrypt plugin should be used to encrypt messages before they're stored. This ensures that if unauthorized access to the server is gained, messages will be more difficult to read. This is especially important because without TLS, anyone intercepting traffic on an open Wi-Fi network could literally see your emails in plain text. IMAP ensures that all of that communication stays encrypted and private.